Okay, so let us today we can have a discussion on this AC voltage regulator experiment. Okay, the name itself indicates that what is AC? AC is nothing but your 230 volt sinusoidal signal, sine signal, where the specification of AC signal will be this AC signal we have given from this. It will be 230 volt, okay, 50 hertz like this, and maximum 5 ampere current rating like that. So normally we are calling it as a 230 volt 50 hertz like this. Okay. So that will be your input AC. Okay. Now what is our target of this experiment? Aim objective like that. We want to have a control over. We want fixed AC to control AC. So for that control AC, we can have the application of two SCRs. If anti-parallel combination of SCR is there, so one SCR will be used as a control for positive half cycle, and second SCR will work as a control for negative half cycle, so that you can have a control over both the half cycles of AC signal. Is it okay?
Yes.
Now second part is you can connect here motor. Motor means any fan. Fan is also one type of motor.
Yes.
Okay. You can connect bulb, light. So light, heat, motor control application you can do by this type of experiment. Okay. So it is very simple. Power electronics means input is AC signal. Our input power is also AC power. Output is also AC, but control AC. Okay, na?
Yes.
Okay. Now coming to next part. Next part means to control these two SCR gate signals, we require gate circuit separately, get triggering circuit separately. Normally for SCR we require triggering circuit. For MOSFET, IGBT, then other power devices we require get drive circuit or base drive circuit. Here it is triggering circuit. Okay. So now here the triggering circuit consists of, this is control circuit and this is power circuit. Okay. And this is given for connection of your CRO. You can see the signal. You can observe the signal on this unearthed CRO. So this socket is given for that purpose. Okay. Okay. So I will show you the this thing. This circuit is normally which circuit now? This is UGT triggering circuit. Okay. Normally these questions are asked to in first unit also and everywhere, that with the help of net circuit diagram explain the gate triggering circuit of SCR. So it is very nicely given here. This rectifier, uncontrolled rectifier is there, simple PN junction diode. Then zener is there to make the constant output voltage. Then UJT is there, so you can have a valley point and peak point. During that period, you will get a single pulse. That pulse will be generated here. So this is pulse transformer. One will be positive pulse, second will be negative pulse, and these two pulses are given to these two SCRs like this. So you can see these two pulses also on CR. So let us have a, what we can say, observation about this experiment. So as you vary this alpha means firing angle. Okay. So what will happen? Will be the see the effect on light. What is happening? You can have the control over light. Correct. So it is very simple. So circuit is very simple. Nothing is there. You can have a small mini project on this also. Okay. And as you are observing here the intensity of light, that means your voltage is decreasing and increasing. That is the case. 230 volt you are decreasing, and then you can increase the voltage like this. So how much, at what level you can increase, that you can see by using multimeter. You can take the observations and you can observe the waveform on CR likewise. Okay. So if you want to see this on multimeter, you can see it. Okay. So multimeter you can see this reading here. Keep this multimeter on AC first. Okay. For AC this is the range selector. And this is the for your selection of any other, that may see here. You can have a, what we can say, range of voltage, and this is, you can have AC, DC, auto, like this mode you can select. Okay, like this. So you must have idea about all the multimeter also, how to use multimeter. So coming to point that as this is AC, I have keep it on AC. Then second, I want more range of this voltage, so I have keep this decimal point like this. So you can measure it like this also. And you don't touch here, because this is 230 volt and the step down AC will be there. So while doing this, you have to take care about all these safety measures also. See, this is the voltage 6.8. As I vary this, it is varying up to how much?
21.7
point something. So this is the max level. So it is step down AC is given here. So because of that you are getting normally if direct voltage is given, then it will be from 0 to 230 volt like this. Okay. So kit is designed in that way. So it is minimum is 4.2 volt and maximum is how much? 22 volt, something like that. So 4 to 22 volt, that range is there, that you can vary the voltage. Similarly, you can see this signal on CR also. So power scope also. Power scope, as you know, that power scope is normally unearthed CRO. That's a probe. Okay. So you can see this. For this, you can turn on this, and these are the two different channels. Okay. You can use any one channel. So now this channel is working. So I have kept it on 0, and then you can connect two probes from this channel, channel 2. Okay, channel 1, channel 2. This is time, and you can measure the time divisions and multiplication factor of time, and thereby you can calculate T, and thereby you can calculate F. So now here you can have a measurement of voltage and observation of the signal. Okay. Probe means only separate wires, not these probes. I want separate wires. Here no need, there is no connection of connecting the probe. Okay. Here you have to connect the banana wires, banana pins. There are so many types of pins, crocodile pins, banana pins. So we have to go use this thing. Okay. One is black, one is red. You can use like this. Okay. You can use anything, or you can have this black and red combination like this also. Okay. And then you can connect it here. This is one part. Okay. And this is the second part. There should not be short circuit of this. So while connection, you have to switch it off, and then only you have to use. Don't directly do like this. Okay. And then you can have this voltage. Okay. So you can vary this voltage. See, the amplitude of this voltage is changing. Then if I vary this, it is increasing. Okay. Keep it like this. Only this much you can see. Okay. You can vary this. So peak to peak voltage and all, you can take the reading of this. Voltage is here. Then you have to keep it on AC actually. AC signal, because AC is output is AC. Don't keep it on DC. If both the signals are like this, then it will be grounded. This is grounded now. You have to keep it on AC. See, it is showing some firing angle also. Okay, this is firing angle actually, but some distortion is there. So you may vary this. The waveform is somewhat distorted actually. What should be the or what we can say waveform shape? You can see here. Actually, theoretically, it should be like this. How? This is your AC signal, correct? AC signal, and you are controlling this. Okay, from alpha to pi, and then what is this? Pi plus alpha to 2 pi. Like this. This is omega t, and this is your output V out AC signal. So it should be like this. So for measurement of this alpha, what we can say, how to measure this alpha? So for this you have to measure this pi, total pi. You can call this as a P period. Number of divisions is P. Okay, and then here you can call it as a N. Up to alpha, from 0 to alpha it is N, and from 0 to pi it is P. Okay, so I can call pi P is equal to 180 degree. Okay, and N is equal to alpha. Barabar ka? It is correct?
Yes.
I am giving this thing. These are the number of divisions. Okay, N is number of divisions, P is number of divisions. Okay, so P is equal to 180 degree and N is equal to alpha. So I can calculate alpha. How? Alpha is equal to N by P into 180 degree. Correct? So what will be the observation table now here? It will be P is constant. You can write it like that. Okay, then you know that AC voltage is also fixed. Input AC is fixed. You can write it here. Okay, and then you have to write n is varying.
Yes.
N is variable. You can see here. You can see n is variable. Okay, alpha is varying. Huh? And then n. Then what will be this thing? Here you have to calculate alpha. Correct, na? Because this formula I have given to you. N by P into 180 degree. Okay? So you will get alpha in degrees, and then you can have a meter here, multimeter, so that you can measure the AC signal. So that will be VAC output. Okay? And then alpha VAC. Okay? So you can vary this. Suppose n is equal to, suppose you can take this first reading. Okay? See now. Here you can take the reading. How to take the reading now? How to take the reading? Don't do like this, huh? Because it is directly AC signal. You are connected to AC. So here you can have this thing. Okay, this is your zero line. Correct? So now I am connecting to this point. Huh? So from here it is varying from this signal. So this total P is nothing but from this point to this point. So how much it is? 1, 2, 3, 4, 5. So here you can write P is equal to 5 divisions. Okay. How much is N here? N is how much? 1, correct? 2 and 3. N किती कैसा करना तो how to calculate N? N is 1, 2, 3. It was 5. So N is 3 now here. Okay. Then you can measure the output reading, that means voltage. Okay. Similarly, you have to increase this. Say the next part. It is increased. That means N is reducing. N is reducing. Correct, na?
Yes.
So 3. Then it will be 2 or 2.5. Second reading will be 2.5. Next will be 2. Then 1.5. Like this you can have. Huh? And then you can take this reading. Then one more thing, you have to connect the load also parallel. Load also. This is without load, no load reading. When load is connected, you can have the change in the signal. See this thing. What is happening? So here, as this is a AC signal, okay, see here. Actually, you want to connect this in a different way. How we can connect it? Not possible. Connect one point here.